Alright, so what we'll do now is we will put all the functionality that we have thus far into a new class called simulation or COVID simulation or something like that, which will be our actual game class, and we'll need to define different types of dots so that we'll have susceptible people, infected people, and recovered people, SIR. We'll model that functionality by the type of collision handling that Pygame has between sprite instances. Okay, so what we'll do is we will make a new class called simulation. The only thing that this thing needs is a width, which we'll set as default to 600, and a height for 80. And then we'll set self.width to this width, so that will be this thing. Self.height will be height. And now we'll make a bunch of containers. Self.susceptible container equals a Pygame group. Self.infected container equals Pygame.sprite.group. Self.recovered container is Pygame. Oh, look at this. Sprite.group. And we also need a container for all of them, because then we can just call the update method on one of these instances. All container. This is the entire population. And then we will just make some initial values for how many susceptible guys and so on we have. So n susceptible is 20, n infected can start with 1. Do we need anything else? Yeah, we need a t time and the recovered container. Yeah, we'll up that as we go. So what else we need now is a start method. And so this function actually starts the game. So I think what we need to do here is these things. We'll initialize the game, and I think we need this variable for later, so we'll just compute the full population, which will be self.nsusceptible plus self.ninfected, and the width and the height, they're member variables now. Need u, and we don't need u, but we can indent u. Instead of adding it to a container, we'll add it to self.susceptible container and to the all container. But instead of iterating up to 100, we'll iterate up to self.nsusceptible. And we'll do the exact same thing for our infected. So now we'll iterate up to n infected, and we'll add the infected container instead, and that'll be the only difference apart from the color, which we will also change. So this will be infected container. So we'll make the infected guys green. Then we need to define the color green. It won't be entirely green, but greenish. There, so now we can actually tell them apart. That's good, yeah? Yeah, these variables, they are member variables. Okay, now I just cleaned it up. So here we have the same stuff as before, it's just on more lines, so you can actually see what's going on. So now we need the this loop thing here. We're going to do almost the same thing. First, let's see if we can do exactly the same thing, but just with one guy that's green, the infected guy, without him actually being able to infect anyone yet. What we'll do now, we'll say that we'll indent all of this for t time steps, and this will be exactly the same, but instead of container, we'll go self all container dot update. We have a screen that we started up here. Yeah, that's fine. Could have been down here, but we'll do the same trick. And right now we are supposed to make to handle cases where they collide, but now let's just try to see if this works. So we'll make a new simulation. Let's just call it COVID simulation and then COVID.start. Width is not defined. I agree. We need to put some selfs here, and the same thing here. Container is not defined. This is on line 124. Oh yeah, of course. Draw all of them now. And there we go. So now we have some blue dots and one green dot, but now they won't be interacting. And now we could define the parameters of our game by simply going, okay, COVID.n susceptible equals 80 or something like that to yeah, there you see. We have just one infected guy. So now what we want to do is we want to check if they are colliding, which we will do here in this game update time loop, right? And we'll do that right after we've drawn on the screen, I think, yeah. So here, do we have new infections? So then we get a collision group if anyone collide, which will be pygame.sprite. This is, I have not been sponsored by the soft drink Sprite, just so you know it. And we'll go group collide, a neat little function. What we do there is we check between two groups if there is a collision. So self.susceptible container, has it collided with self.infected container. And now we also have the option to remove anyone that has been involved in the collision. And what we'll do, we will remove the ones from the susceptible container, but not the ones from the infected container. They will still be infected, but we'll remove the susceptible ones. And what we'll do with these as for, I like to call them guys when I iterate over things. In collision group, this will contain all the dots that were involved in the collision. We'll say that we create a new guy, and we do this by implementing a respawn method. So we'll go to our dot implementation and do this now. And the reason we need to do this is we need to change some of the attributes, and we cannot iterate over something and remove stuff from it. So what I would actually like to do is to iterate over all these guys in the collision group, and then remove them from the collision group and then add them to the infected group, right? But we cannot do that because we cannot. It's not very wise to amend or change something that you're iterating over. So we'll actually create a new one with the same attributes, and we'll do that by, here is our dot class, by introducing a new method called called respawn, and there we give them a new color, have the same standard radius. So the only thing this does is return a new object of the class with all the values. Self.the x value is in rect.x, the y value, and then we'll have a width that's also here, the height, the color will be the new color inputted in this this function, and we will give it the same velocity, I think. Yeah, and that's really it. So this function creates a new one that is a copy except for the color. That's my idea for doing this, at least. And this will be a green guy because it will now be infected, or that's the idea anyway. And what we'll also do is we will change the velocity of it, of the new guy. We're making it go the opposite way, so we'll actually see some sort of collision, bumps into it, and then whoop, bounces off. And you get a bit startled when you get infected suddenly by a virus, right? And right now they are supposed to recover after a while, but let's wait with that. The important bit is to add it to the infected container. And because we killed it, we also need to add it to the all container. There you go. Okay, let's see what happens now. Let's go. It runs. It might take a while before you actually bump into anyone there. Guy. Here we go. Yeah. So this is the functionality we wanted. Already we have a lot of infected guys. Cool, huh? Now, let's look at actually having people recover. Because we have a recovered container, so we need to put some people in that after a while. And then I think we need... It has to take some time until they recover. So we need some sort of switch in the dots to say that, okay, you have been infected. This is how long it takes until you recover. Or it could also potentially die, right? We will go up to the dots implementation, and then we will add a, say that, okay, a kill switch. Kill switch on. And we'll say at the moment of creation for this dot it is false, but we will also add a new function called kill switch, and then we can start counting down. The fate of this dot will be decided in a set number of updates or cycles. So we'll say cycles to fate and set that to 20 as. And we'll also have a mortality rate, which is some percentage. We'll put it at 20% as default, and we'll say that kill switch on is now true. Self dot cycles to fate is cycles to fate. Self dot mortality rate equals mortality rate. And for each time a dot is updated, if it is infected, or the kill switch is on, we will check for that. So this is the update method. So we'll see if self.killSwitch on, then we'll reduce self.cycles to fate by 1. And if this self.cycles to fate is less than 0, less than or equal to 0, maybe, we'll set self.killSwitch on to false, so it cannot die again or recover again. And then we'll compare the mortality rate to some random number, np.random.rand. That will be a random number between 0 and 1. And if the self.mortality rate is larger than this number, then we will kill it. And self.kill, this function is a function within the sprite class. So we have inherited it from the sprite parent class. And else we will say that self.recovered equals true. And I think also we need to initialize these variables. So we say that self.recovered is false. It hasn't recovered yet. Oops. What we want to do here is to activate the kill switch. This sounds morbid. Here. And let's also set these variables up here, okay? So we have self.time to fate, or cycles to fate, right? And the standard was 20, so we can do that as well. Self.mortality rate will be 0.2. We can change them. So we'll activate the kill switch and input self.cycles to fate and self.mortality rate. Right? Yeah, okay. So now they can recover, but we don't do anything with the dots that do recover. So we need to check for recoveries. Okay, so this is new infections, and now are there any recoveries? If the dot succumbs to the disease, it's simply removed, and it won't be any container anymore. So here we will check if they have been recovered and then add them to the recovered container. So first we'll just go through them all and add them to a recovered list. So for guy in self.infected container, if guy.recovered, not spell that correctly, and up here recovered, yeah. So if recovered, then we will make a new guy.respawn, use the color purple that we need to define. A nice purple color is 130, 0, 130. Almost there until we can test our game, which will be very non-interactive, but still, okay. So we make a new purple guy. Yeah, so so we need to add the new guys to the recovered container. Dot add new guy. Let's also add the recovered to. So this is the output from the iteration. So we'll add the dot instance there as well, and you'll see why now, because we need to remove them from the infect. So let's check if there was any. If the length of this recovered list larger than 0, yeah, then we will infect the container and then remove all the ones from there. And we'll also remove them from here because we spawned new ones and we didn't put them in the old container. So this is the new guy. And then we draw them. So I think that should work. I hope you got that. Game mechanics is, there's probably more ways to do it as well, but it can be a bit tricky. Usually I've forgotten about some sort of edge case. We already did an error on 179. Let's see. Let's add. And I think now the recovery time is so short that we won't actually see a lot of infections. And there we have some infections. He died. And there we have a recovery, another recovery. Yeah, cool, eh? It's working. Yeah, and now they're all recovered or dead. Yeah, there's one guy left. Yeah, so to make this a bit more interesting, what I want to do is I want to introduce some random dithering, some random walk element into this this thing. So what we'll do is we'll add, actually let's copy this, and we'll say that in the update here, if self.randomize, we say that self.velocity equals this. So we'll add just something a bit random. We'll say that self.randomize is false, but we can, no, let's take it there actually. Randomize is false by default. You have the option at construction to add it, and then we also, should we add it here? Yeah. So randomize is usually false, and then we'll add it to the susceptibles when we construct them. So randomize equals randomize. So that's up here, yeah, and here as well for the infected, yeah. And then when we start the game again, we will say randomize equals true. Let's see now. So now it's much more erratic. It's a bit too fast, I think. And yeah, let's also do something with the what was I thinking about? Yeah, the mortality rates. No, the cycles to fate. 200, yeah, that's a long time. The entire game lasts for 1,000 cycles, remember? Okay, it's a bit fast, but here we get infected guys all over the place, and now the entirety of the dothood, the plant of dots is doomed but most of them recovered probably. Yeah. Okay, we need to do something about that velocity. So we'll normalize the velocity after. Yeah, I have an idea for that. Hold on. So up here, we will check. We'll compute the norm of the velocity. Velocity norm equals, well, numpy dot linear algebra dot norm of self dot vel. And if, well, norm is larger than 3, yeah, so if it would reach some sort of velocity, we will say that self dot vel, and it will divide by the norm. So now it's actually normalized down to unit length. So can it reach a very high velocity? Let's try if that's any better. Maybe. You can play around with these parameters on your own. But now let's just try something. So, and then we'll have infected can be 5. Oh, it goes fast. So many infected people. It's cool, eh? Cool.